The Australian Government Summer School for Teachers of Mathematics was held at the University of New England in January 2008. Teachers from across Australia came to hear high-profile presenters discuss issues related to contemporary teaching of mathematics. Andrew Johnson, a structural engineer with Consulting Engineers Arup, presented a seminar entitled Mathematics in Engineering. Andrew, I was wondering if you can just tell us what was the main focus of your presentation.
Yeah, Russell, I tried to focus on the relevance and issues in mathematics or fundamentals in engineering on the basis of teaching mathematics, particularly secondary school. Mm-hmm. So the fundamentals we looked at were geometry, just basic geometry, its use and its currency in engineering moving forward, and the concepts we use today, and also particularly in differential calculus and the basic teaching of those methodologies that we use today.
Right. So can you just outline what you think might have been of particular relevance to teaching of contemporary mathematics?
Yeah, I think for me, when I was putting the presentation together, I was looking back at my time when I was being taught in secondary school. And one of the things that didn't really have then was a context or an inspiration. And what I tried to do was put a context and an inspiration through a series of case studies into the teaching that is being undertaken at the secondary school level.
Right. This seems to be a recurring theme from the presentations that have gone through, and I guess that's what the summer school has done by bringing people from industry and government sectors where they're actually applying mathematics and trying to give an insight to how that might be brought forward to the students and help to motivate them. I'm just wondering if you can tell us what you think might be the key ideas and messages that you'd hope that the summer school participants might take back to their school.
Yeah, to me I think the key, and I got a bit of this feedback from the delegates and talking to them, was that they could take away something that they found they could use in their teaching and gave students an insight into what they might be able to do in the future, whether it be in a professional sense or it just helped their understanding and learning, that they could give a context to what they're being taught. Yes. And for some of them that may form a profession and give them a direction they want to go in, for others it will just help their learning, but it will give them something that will just help inspire them even for a short period of time in a certain subject. Yeah.
I guess in a sense engineering is one of those areas where you can view maths in an everyday setting and see it around you every day. I wonder what sorts of things the teachers might actually be able to take back from the presentation and apply in the teaching context.
I think especially the geometrical issues. I think when you look, certainly as a structural engineer, when you look at buildings, especially those with expressive structures like stadia and tall buildings and the like, you see that around you every day, and when you have the basic principles explained to you, you then can understand it in another level that you can easily take back into the classroom and teach. We focused on, in particular emphasis on, we looked at the building known as the Water Cube in Beijing. I think a lot of the teachers are extremely interested in that as a current building that was based around a novel geometry.
Right.
Through a bit of research, and they could take that back and use that as an example. Right. A case study of quite simple geometry that's being used now. You know, geometry that was well, is hundreds of years old, is being used in modern projects.
Right. Great. The summer school will be presented on a website, and there'll be resource materials there related to each of the presentations. Are there any other resources that you might direct teachers to that would help them in addressing the sorts of issues that you've addressed?
Yes, definitely. I mean, there was certainly we talked about some fundamental papers just on new uses. There are some texts and papers out there on fundamental uses of engineering and or mathematics and engineering, and that are broken down and simplified down. I'm going to put together a list of those for them. Yep. But also these days, obviously the web.
Yes.
And there's an immense amount of information on the web. The Water Cube is an example. We did go through that with some of the teachers in the last one, and there's been over 300 papers written even externally to Arup on that building. Right. We've got a few of our own as well that are in the public domain, and you find that with most interesting engineering problems as these days, anyone can find a lot of information out on the web.
Great.
Very much so.
Well, thank you very much for the information, and I'm sure that the teachers will be looking forward to trying to apply these areas in their teaching. Thank you again.
I hope so. Thanks, Russell.